How do you want to be presented? Just the name.
Just name, and I can present. Go and take from there.
Hi everyone. I'm going to start the presentation of Hanno Krosing, and please switch off your phones in a minute and enjoy.
So hello, my talk is about how to scale Postgres to however large volumes you need. The title is inspired by some joke about scaling one NoSQL database, but it's actually true that anything you can do in at least mainstream NoSQL databases you can also do in Postgres if you dump it down enough.
Okay, can you speak up a bit louder?
Okay, is it loud enough? Even more louder? Okay, I'll try to keep it like this. So, first, my name is Hanno Krosing. Currently, my main job is as at second quadrant. Skype name also, if somebody wants to ask direct questions later. I've been using Python since forever. I think it was something version 1.1 when I started, at least. Also, I'm using Postgres even before it became PostgreSQL. It was the language in Postgres at this time was PostgreSQL as an extension of the old Ingress query language, QL. So it was about in the late 80s when I first touched Postgres. And I'm also a small-time hacker and contribute to both. There are maybe a few tens of lines of my code in Python and maybe 100 or so in Postgres. I contributed to Python the support for Pascal strings in structs module. This is my claim to fame. My first experiences were really needing to scale Postgres were when I was the DBA at Skype. Skype has always been running Postgres as its main database and still is, even now that it's owned by Microsoft. I heard that there have been some tries to move away, but nothing very successful yet. And since 2007, when Skype was sold to eBay, the first big sale of Skype, I have been the full-time PostgreSQL consultant, more or less independent, or actually a part of a bigger group of PostgreSQL experts called Second Quadrant. Quite loose group of top experts all over the world and work both independently and as a group. And I also am a technical advisor to the venture capital company of the Estonian founding engineers of Skype. So the four main guys who wrote Skype got a nice sum of money out of it and put at least, I don't know how big part, but enough to fund a venture capital company, and now they're investing in the plan was to invest mainly in the local region, but now they are actually investing all over the world in early stage startups also. So if you have anything already going, not too late stage, then you may try to contact them or us. I have also authored two books on Postgres. First is PostgreSQL 9 administration, and the second one is PostgreSQL server programming. It is, I'm not sure if it's out already or in a few days. All the chapters have been turned in about a month ago, so it should be out by now. At least you can already buy it. And the latter book includes basics on using PL Python And PL proxy. The PL proxy is another language I'll talk about in this presentation. This is the main powerhouse behind the scaling of Postgres as done by Skype. So, what is Python? Okay, I'm just kidding. Most of the people here knew what is Python. It's a very dynamic language. It's really flexible in what you can do when defining your own classes. When it's object-oriented, so everything is object. It doesn't have a distinction between non-objects and objects, like for example Java has. So absolutely everything is an object. It has good introspection. You can type help for almost anything, and if it's reasonably written, then you get usually enough info at least about basic usage. You still have to read documentation sometimes. And it has libraries for almost anything you may want to do. So, what is Postgres? Or PostgreSQL? It's almost always written as PostgreSQL, but quite often it's spoken as Postgres for historical reasons, because it used to be Postgres before it acquired the SQL part. So both spellings are right, but if you write it down, then it's always PostgreSQL and never Postgre, as I've also seen it written. So first, it's the most hackable relational database I have seen, at least from the ones that are ready to use for anything serious. And it is designed so from the very beginning, meaning that it's built from ground up with extensibility in mind. It stores lots of different object types, and almost everything is defined in system tables, which means that first, of course, if you create a table structure, it's stored in system tables, which is kind of, I guess, everybody does that, but much more. It also has objects which you can or functions which manipulate these objects, which are also stored in system tables. Okay, but it also has operators stored in system tables, which means that, for example, if you do something like select 1 + 1, then actually the meaning of the operator is also looked up in system tables. And then it's matched to the types of the operands, and then the underlying function is applied. So if you want to play tricks on somebody, try redefining the plus operator to something else and see them try to debug this. And it's and it's very much like Python's classes add and other customization methods, where you can make every type behave differently. The syntax in Python and Postgres and actually how you do it is different, but most of the possibilities or capabilities are there. Also, there are other things like types, casts, all the types like integer, text, internet address, more esoteric things like geometric types. Everything is defined in system tables. So if Postgres sees something, then it reads in the thing. Usually, if you don't specify in your text input, then usually it ends up being initially either integer, float, or text. But if it needs to be put in a table and defined as another type, or you explicitly cast it to something using one of, I think, 3 possible syntaxes. One is just the type name and value, the other is value, double colon, and type name, and so on. Then again, type input function is looked up in system tables, it is applied, and then already it returns the binary representation of the type, which is used internally by Postgres. Same if Postgres sees that it needs one type but gets another, then it looks up cast functions again in system tables, and so on. So everything that goes on is also dynamically definable. And one thing where Postgres is also different from others is that all the DDL or data definition language, create table, alter table, create index, drop table, are transactional. So you can create table, create a few indexes, drop another table, and if you in the end do a rollback, then everything is as it was before. One thing to notice is that because Postgres by default operates in auto-commit mode, then you must start it to begin for this to happen. Otherwise, each command is its own transaction, and the end of command also commits the transactions, unless there was an error, in which case it is rolled back. But the introspection is not available that much on server side. There are functions for a few things, like getting an index definition, getting foreign key definition. But lots of it is available in PSQL, which is the default client. And if you need to use the introspection capabilities in your own programs to find out something about tables, to do some interesting metaprogramming, then the easiest way to find out how to look it up is to start the command line client to -e option, the large E. Small e is just echo. It echoes whatever you put in, but major E also echoes whatever the system itself or the client itself sends to server. So if you use PSQL's description facilities, things like \DT, which is for listing tables, or just the table name, which lists lots of information about the table, then PSQL -e shows all the SQL queries that are sent to the backend. So if you later need to do something similar, then you just copy-paste these queries, substitute in your parameters, and you can use them. And the one thing that is quite often overlooked is that Postgres is not just an SQL database, but it's actually a powerful multi-language server platform. You can have multiple embedded languages. The core development group manages PL/PGSQL, PL/Perl, PL/Perl-U, PL/TCL, and of course PL/Python. And as you see, then PL/PGSQL and PL/Python have only one version, others have two. The reason is that if you have the U at the end of the language, it means that it is untrusted. And untrusted doesn't mean that we trust the language to do what we call it, but it's rather untrusted in a sense that you don't trust sharp knives to children, or so, that it's something that is very capable and powerful, that can do more than you may want your users to do. For example, the untrusted languages can read files, they can open sockets, they can send signals. Basically, they can do anything that you could do if you were running as the database, as the user of the database is running as. And this quite often includes stuff you don't want your ordinary users to do. And because of this, the language is actually, it is not PL/Python, it's PL/Python-U. Python comes only in untrusted version. There used to be at some point also the trusted version, but because most of the sandboxing that has been attempted on Python has eventually failed, because there are so many things inside Python where you can bypass all kinds of sandboxing checks. I know that now there are two kind of sandboxes that should work. One is from the SOAP and the other is the PyPy. I will talk briefly about the PyPy one in my tomorrow's talk. But basically, as the main C Python developers have given up on sandboxing, then by default Postgres also supports only the untrusted version. And untrusted version means that you must be a database super user to use this language to define functions. But it's about defining functions. You still can assign the right to use the functions to any users. It's just that you can't do create function with untrusted languages. So now we have gone over the Postgres more or less, and let's move to actually the scaling part. Have any questions about the Postgres part yet? Okay. So let me first describe how databases usually tend to grow. So first you have a single database, it runs quite well, everybody's happy. At some point you launch your product and you start getting users. And if you are lucky, then you get lots of users. And then at some point your database doesn't run very well anymore. There is either too much data, too many users pounding the server at the same time, or any other possible problems that come from growth. So what people usually do at this point is you start splitting out some functionality to a second database. At Skype, we first had just a single database for storing user passwords. Then at some point we started making money, which meant that we started selling something, which in case of Skype was selling calls to landlines, which needed a quite large accounting database, which also interfaced to calls database. And once you have a few thousands or tens of thousands users calling, and every minute they check if they have still remaining balance, then at some point it doesn't work very well, especially if you also let your analysts to work on the same database to run ad hoc queries, which sometimes go wrong, and then all kinds of things happen. And the vertical scaling still solves most of the problems for some time, but at some point you hit a table which is too big, which is a single table, single functionality. You can't move that to a secondary database, to a second database, and ease your load this way. And it's a split, not split. Usually you split by some well-defined thing. In case of Skype, we split by username. Actually, we used hash of username so that we didn't have to guess any other distribution characteristics. First, we split it to two databases, later three. Latest I've heard it was over 100 shards that they were using. But basically you just put different user groups into different databases. And once you have started doing horizontal scaling, you discover that things work better if you undo some original vertical splits, which means that you still want the data related to a single user to be in the same database as this user. Otherwise, you need to go the NoSQL way and start doing most of the work in clients. But as we are used to doing, actually letting databases do database work, then it was much better if that related data was together. And if through all this you have been lucky, then the clients really haven't noticed very much what you have done behind the scenes. For clients it still looks more or less as it looked in the beginning. So, why were we able to do that this well at Skype? One of the basic things we did from the beginning was that all database access was done using functions. So whenever something needed to be done in a database, then the clients never issued any complex selects, inserts, updates. It was always select from function. People tried to be smart, and sometimes they made a join over free functions and did other cool stuff, but we soon caught them and enforced that it's always just select from a single function. For example, at some point they managed to do a euro to euro conversion, which took more than a second because they used free set returning functions and made joins on top of these. And when things were in functions, then the database guys were able to fix and optimize stuff. If you do stuff on the client side, then it's much more involved with everybody. It's much harder. So basically, if we want the user to log in, we just send, this is all, again, this is basically not exactly how it's done in Skype, it's more or less how it's done in Postgres itself. Basically, you send a double hashed password and salt and username. This is so that you can't use stolen credentials. The salt is new for each session. So this is also how Postgres itself does its authentication. And from this single-minded function use, when we started doing vertical scaling, then at some point we needed to, from one database, to execute some code in the other database, which meant that we wrote some functions in EuroPython, which basically connected to a second database, and then one query in the second database. It is this is now already not ACID compliant because transactions into the database are not the same, which means that you must take care what you're actually doing inside the databases. But again, as it was us, the database guys, doing it, we knew to do it sparingly. We were able to do it in a way that maintains consistency. For example, we didn't automatically decrement money amounts in the second database. We just reserved it and then let later the actual transaction be replicated to the second database, then applied it there, then replicate the result back, which is the kind of standard base or basically available, eventually consistent way of doing it. And because each database itself was ACID compliant, it was even not very hard to do it. You just had to consistently pay attention. And we didn't need very much of these functions that did stuff between databases. Because most of the related data was still in the same database. And when we started doing horizontal scaling, then we basically extended our EuroPython remote calls to actually select which database to use. So first we used username hash, and this example is for 2 partitions, and to use the last bit of the hash to select one of the 2 node names, actually node connect strings, and then connect it to that database and later run the function there. And soon we were doing this more and more often, which basically led to invention of a new embedded language called Proxy. And in Proxy, the whole function here, some of it is left out, looks like this. First to define it as cluster users, and then we just say it run on username hash. Actually, it's in Postgres, it's hash text username. It's copy-paste error from Python. this syntax does. Okay, my laser ended working. This syntax in Postgres would mean that we have function hash in schema username, and then it's hash over nothing, and it doesn't work. I will fix this before putting the slides up. So once more, and this way you ended up doing almost all the scalability in PL proxy in Skype. We have an extra thing for replication. I'll mention it later, but don't talk about it too much. But basically, all the functions will go through two databases. First is the proxy database, which selects the real database, and then the work gets done in a real database. And the overhead of this is typically much less than a single millisecond. So it's not really hard on anything. And also because mostly you don't do things in using only one thread, but you have a problem is more serving many users, then even this millisecond gets hidden. So you don't see it almost anywhere when you look at profiles. I mean, you don't see it as a slowdown. You still see it as some slight CPU usage on some servers, but nothing else. So once more, why is poor functional interface to database a good thing? One thing we do when giving client programs access to functions is that we don't give them access to anything else. They only see a small subset of all the functions, only the ones they need to see. So basically we end up a thing that in Java world is known as SOA, or service-oriented architecture. We just have a bunch of functions that clients call, even though the functions are implemented in either SQL or EuroPython or sometimes something else. Sometimes also C if really much speed is needed. But you don't have anything that users can do damage to. And one of the things that it comes to is that SQL injections just don't work. You don't have any table to drop. You don't have anything to delete from. You don't have anything to change. You only have functions to call. Second is ease of maintenance. Most bug fixes and upgrades really don't need any scheduling of downtime. If the client side, if there are no large client-side fixes, usually they can even be kind of disconnected. Of course, you still need to test everything well, but the actual deploying doesn't need to put new code on some 200 servers. You just change the function definitions in the database, and that's it. The function starts to work differently than it did before. For example, this when Skype was in early growth phases, we kind of were running at 80% capacity and growing 25% per month. And then for some reason buying the next server took 4 months. And which meant that we had to just optimize ourselves through this period. And it involved lots of intense optimization work, some full rewrites of some parts of underlying schema, but it all was done without any changes to client side. Clients still were just calling the functions they needed. And we learned quite a lot about optimizing Postgres in this time, and also sometimes about failing to optimize, which also happened, unfortunately. But we managed to do it without any major failures. And another thing is it makes it very easy to monitor and audit stuff. You just put whatever you need there, and it either starts getting logged or starts getting sent to some monitor. For one thing that we needed to put there, and which is generally a good idea for most cases, is detection of brute force attacks, for example, to login or any other function that requires user credentials. And we didn't need, again, to add anything to client side, even though in the end we did. But we achieved the actual functionality by just keeping logs of latest activity, and in the login function consulting the log if, for example, if in the last 10 minutes this client IP has failed to log in more than some time of numbers, then we just started delaying stuff. And also we check that there are not very many parallel attempts on the same database. But again, all this can be done inside database without distracting clients. One reason, of course, why we prefer to do stuff in database, because PostgreSQL is open source. If it would have been very expensive, like some commercial databases, then some of the optimization, and especially financial optimization advice, doesn't make much sense from the technical point of view. I even recently heard advice, for example, to not sort in database, but do it on your cheaper CPUs on the client side. So lots of these things. But if your whole stack is open source, then usually doing stuff near data is faster, and it takes smaller amount of resources in the end if you do it near the data. You don't ship the data back and forth all the time. So I have heard complaints that if having a function-only interfaces could be too limiting. But actually most of the problems that relational databases have when scaling come from trying to solve the whole problem, to have a whole view of database which is all consistent and durable and isolated and so on. And as the database developers and vendors have found out time after time, this just doesn't work. You have to make your task simpler. And this is, for example, what most NoSQL databases do and why they scale so well. It is if you push lots of work in the client side, then it also takes most of the responsibility for consistency and stuff, and it makes your just storage much easier, sometimes faster, and also much easier to scale. But as databases have lots of development work and brain work of lots of smart people behind them, then if you are dumbing down your task, then you find out that most of things that are needed for doing this simple thing are already there in the database. Even if it carries along lots of stuff that you are not going to use, it's still usually fast enough and good enough for other tasks that newcomers are just starting to discover. All kinds of things related to databases bigger than memory, to parallel execute, to have many parallel things, and these things are all old news for established relational databases. And even though at some point it may look that the PL proxy is kind of just, in some view, in the view of simplicity, from the user side, it looks like you are doing just key value store splitting. But because each of the partitions is still ACID compliant, it is actually makes the programming task much easier, because you have all the related data in one database, and you have to do the base tricks or basically available eventual consistent tricks only when you are dealing with data that is not split, or that must be the same for all users. One typical example is, for example, price lists, where you want to have a new price list take effect at some point. And usually you don't try to update it at some point on all the partitions. You rather replicate it in much earlier and have your function that uses the price list, or view that use the price list, just check for time. At some point it just switches to new price list. So you avoid most of the problems that come from trying to synchronize things together into a single point of time on multiple hosts. And if you are really just a function interface, then you could, for example, make a decorator that actually exposes a Postgres function as a Python function if your client is Python. I have done these and a few others which basically make your task easier. It's then one or two guys who make these decorators, and application developers just use the functions as if they were Python functions. They don't even need to know which ones are executed in the database. And it will actually execute something like this in the database, and then bring back the result and give it to assign it to the res transparently. And you can have others also that have more checks. For example, that you must have exactly one row, or you can have something that really deletes something. One thing that happens quite often with Postgres or SQL database in general is that you can silently fail, for example, delete or update. It says that everything was okay, but actually updated or deleted 0 rows, which is usually not what you want. and in these cases, you can solve it in decorator. You don't have to make extra checks there. So what does PL proxy do? It's an embedded language with sole purpose of querying other databases. It can just proxy calls, which means that it just calls the same functions in another database, or it can select the database based on various criteria. Most often you do it based on some partitioning value. Either you have, which we mostly use, that Skype was #text username. You can have also some special number you maintain. You can also route to the user's closest database for some things. It's all very flexible because you just use a database function for this that you yourself define. But also you can see anything else, even not based on criteria. For example, you could use one database or the other depending on the time of day. So for partitioning using PL proxy, you need 3 functions. One is partitioning function, cluster version function, and cluster config function. The important one is the partitioning function, which basically returns a list of connect strings which PL proxy uses to connect to partitions. And it must return a power of 2 connect strings. In this case, it is partitioned between 2. The other is PL proxy get cluster version, which is checked if by PL proxy language handler to see if it must reload the configuration, because configuration function itself can be slow, and also PL proxy caches the connections. Then it must have some way to know if it needs to redo it. And basically it will call the configuration function a second time if the cluster version has changed. And there's an optional functions which gives things like a connection lifetime and so on, some optional parameters that are not really needed. And once you have these functions, you can write a proxy function which looks like this. It has only 2 clauses. First, which says which cluster it must run on, and the other tells where to run. And that's it. All what I described before still works. You still just call a function database, and it now magically runs on the right partition. And say first, and many partitions can also point to the same host, which means that your partitioning functions in this case would return 16 rows, first 8 pointing to the node 1, node 0, and the other 8 pointing to node 1. And what I mean by really scaling is that at some point you may want to have a third one. And what you then do is you can have you just move some partitions to next nodes. What we use for that is the standard replication solution from SkyTools package called Londist. Yeah, and then we basically make a new partition table in a database, and then when we move data from the main table to this partition, we also replicate. And once the replication is done, you stop the flow of client commands. It's done using a capable connection pooler called PG Bouncer, which we also developed at Skype. You can tell it to pause, then it waits for all running queries to databases to end. When it turns to your command prompt, then you say reload, it gets new configuration, and then you say resume, and then it already uses the new configuration. And the new configuration will already be the one that also uses the third partition. And so basically you have some extra copying moved away. At some point you should also drop the replicated partition from the 2 first databases. It's not strictly needed for this run-on queries, but you may have also run-on-all queries, where you can actually push out the same query. For example, if you want to count all users, then you count all users on all partitions, and then you do sum on top. But basically, it's quite often nowadays known as map reduce. You run something on partitions, and then you do a step on top of it. Okay, we're out of time also.
So we have the questions. Here it is.
Thank you for your talk. I have a question. How can you use functions with an ORM, such as Django or SQL Alchemy?
You must make something in SQL Alchemy. I have actually implemented the decorator that runs a Python function in the backend, and I think something along these lines could be used. I have actually 3 versions of it. One that just has a runner version, which accepts bytecode and arguments, and then runs it in database, gives result back. I have a second version which detects that this function is not yet defined, then defines and caches the function and uses it later. And I have a third one which actually creates a visible function which can then later used by PL proxy. Yes, and I'll try to get them out on GitHub or somewhere so that other people could also play with these. It's still something that I have not done, but I promise I will.
Hi. One of the selling points of NoSQL databases is automatic failover and replication and redundancy. How do you deal with that? Do you have automated failover systems? Or?
No, not in Postgres. we use things like Linux HA to detect, and then you have scripts that actually reconfigure PL proxy to use the new databases. And from the client side, you can have as many proxy databases as you need. It kind of also scales the capability, even though usually the PL proxy is not a bottleneck. But for example, if your data payload in function is large, then you also can have bottlenecks there. And so if you have, say, 500 backend databases and only one proxy, it may become a problem. But if you have 500 backend databases and 500 proxy databases, then the load is distributed at both sides. So it's mostly in these kinds of scenarios, the client layer also must know something about, at least to reconnect after failovers.
Okay, great. Thank you for your talk. It was really, really nice. I was actually about to ask the HA question, but I have a second one that I can ask as well, which is interesting. The main point why people try to keep everything in one code base is because it makes it much easier to version and to reason about. I can see where this doesn't quite work now in your examples. How did you guys do that in Skype? How was that the DBA team that was doing the code review only on the functions that were in that code base, and then there's all the rest that all the other people did? Or did you have one large pool of people? How does it work?
Initially, it was me on the database side and lots of PHP developers throwing in all kinds of code, and I went in when something didn't work. But during the course of a year or two, it kind of crystallized into us having a DBA team which actually did data manipulation functions, and then the UI team which used them. It's the standard model view controller thing where you have a view which is the UI team, and then the controller which is inside the database in this case. So the controller's part is the data manipulation functions plus data all in the same tier.
So you moved large parts of your application logic into the database?
Yes, almost all the application logic that manipulated the data was there, which did something else was outside, but all the data manipulation was near the data in the database.
All right, thank you.
I'm not sure whether I've misunderstood something, but how does foreign files or foreign tables fit into this sort of scenario?
Foreign tables came later. So before it, we could do some of the foreign tables functionality. As I mentioned, we did remote calls using EuroPython functions. So because you can do set returning functions, then we basically asked for foreign stuff from my other data, and then we returned it like a table. They could then be used in the local functions as if they were a table. You can even put the view on top of set returning function, then it even looks like table. But now that there are foreign tables functionality, some of this probably could be integrated. We are still not yet sure how exactly, but it should be something there.
Something I've always wanted to know is what's the best way to test PL/SQL and stored procedure type functions from your experience of working with them?
What I have done is just first hope that it works, and if it doesn't, then I use notify, so it gets things just back to client. Sometimes I also push up debug level and then see what more happens. But mostly it's the old-fashioned way that you just basically it's not testing, it's debugging. For testing, it's still some kind of test framework, and you could use what Postgres itself uses, that you have a set of things you throw at database and then check that the results are same. The basic regression test framework. Postgres has its own regression tests framework. So basically you have a set of tests and set of expected results, and then you compare if you get the same. So it's you feed it the SQL file. So it's nothing very complicated. So
how does sorry?
Yeah, please.
How does you guys were using Python a lot, and I started looking into Postgres a little while back, and people tended to recommend not to use Python because it's an untrusted language and it doesn't run in the same sort of environment. And then they were telling me to use PLv8 instead. Like your recommendation on this?
If you require this kind of sandboxed environment, then PLv8 would be also my recommendation at this moment.
No, I just need
for sandboxed things.
I just need something that really works. I don't want it to break, but I don't really mind. I'm in full control of my system. I just really don't want it to break.
What we have been doing is that if it's just plain data processing, then it's most. Then we usually use PSQL. It is it's not good for anything else, and its console structures are quite awkward. But if it's just data processing, then it's good enough. And it's I think it's the most tested thing. Sometimes you can even use pure SQL, but PGSQL is a bit faster because it automatically caches query plans. So which just using SQL as embedded language doesn't do. So it depends. But if you need to do anything fancier, read files, send email, whatever, then I use Python. But also some people use PLv8 for things like JSON processing. And now in the latest two versions, especially 9.3, which will be out in a few months, the JSON functionality itself has improved very much, so you can do all the, not all, but most of the needed things already using existing C functions in database.
The decorators you showed, are they available anywhere to play with on GitHub or something?
I'll put them up in GitHub. And then try to put, when this goes up, then this will have the links also.
Okay.
Okay, the time is over. So if you want to continue, I advise you to continue during coffee break. After the coffee break, there shall be the poster session in the same place. And don't forget this evening about the Google Code Jam. And finally, you are suggested to vote the quality of this talk in the guide book on your smartphone. Thank you for watching.